So in this video, we will go over a few examples of L'Hopital's rule. As we said in class, we use the L'Hopital's rule when the limit ends up. So if we have f of x over g of x, so we use the L'Hopital's rule in case 1, where f goes to 0 and g goes to 0 as x approaches to a. Or case 2, if f goes to infinity and g goes to infinity as x approaches to a. So in these two cases, we are allowed to do the L'Hopital's rule. So we'll do these two cases. And also we talked about the indeterminate forms of the type infinity minus infinity and 0 times infinity. Okay, so let's do example 1. We have limit of 1 plus cosine of x over x minus pi squared as x approaches to pi. So let's first examine what happens with the numerator and the denominator. So cosine of pi by direct substitution is -1, which means 1 plus cosine of x, the numerator, approaches to 1 minus 1, which is 0. And the denominator is straightforward, x minus pi squared as x approaches to pi goes to 0. Or as we have done in class, we just say that the numerator clearly goes to 0, the denominator goes to 0, so we are allowed to apply the L'Hopital's rule, okay? Which brings us to the limit as x goes to pi. So I take the derivative of the numerator, right? I'm doing this step by step. You don't really need to write that you're taking here the derivative, but just for everybody to be on the same page. Derivative of 1 is 0, derivative of cosine is negative sine of x. In the denominator, I have 2 times x minus pi times the derivative of x minus pi, which is 1. Okay, now again, I apply direct substitution, or in other words, I check what happens with the numerator. Sine of pi is 0, so the numerator approaches to 0, and the denominator also approaches to 0. And in this case, what do? We just we apply the L'Hopital's rule one more time. So x goes to pi. Derivative of sine of x is cosine of x with negative in front, negative cosine of x, divided by derivative of x minus pi. Derivative of x is 1, derivative of pi is 0. So the derivative of this expression here is just 1. 1 times 2 is 2. And now use direct substitution. Right away you can see that in the denominator I don't have neither 0 nor infinity, so this is not going to be a problem, right? It cannot end up in indeterminate form, so everything depends on what is going to happen with the numerator. So that's equal to cosine of pi over 2. Cosine of pi is -1, so minus -1 over 2. That's 1/2. So this limit is equal to 1/2 after we applied L'Hopital's rule twice. By the way, maybe I should have said this at the beginning of the video, but the best way to practice this is that once I write down the problem, you try by yourself to solve it and then check your solution, check your method with my solution. Okay, now let's do another problem. The limit as x goes to 0 from the right of ln of sine of x over ln of sine of 2x. Okay, so here it's always a good idea to have in your mind the graphs of these functions. Okay, so this is ln of x and then sine of x. So what happens first? First is I'm approaching to 0 from the right. What happens to sine of x? And by the same logic, the same thing will happen to sine of 2x. As I'm approaching to 0 from the right, obviously sine of x goes to 0. Goes to 0, but also from the right side, right? You see all the values that this function is obtaining are positive. Although they're going to 0, they're positive. Well, what happens with the ln function as we're approaching 0 from the right? The function drops to negative infinity, which means that the whole numerator goes to negative infinity. Similarly, the denominator, right? Sine of 2x as x approaches to 0, 2 times x as x approaches to 0 will go to 0, also from the right side. Sine of something that goes to 0 from the right side will go to 0 from the right side, and then this goes here to negative infinity. Okay, which means that we can apply the L'Hopital's rule. I have infinity over infinity type of limit. In this case, I can apply the L'Hopital's rule. Take the derivative of the numerator. Here, please be careful with the quotient, with the chain rule. So that's 1 over sine of x times derivative of the sine of x, which is cosine of x, over derivative of ln of sine of 2x. The derivative is 1 over sine of 2x times the derivative of sine of 2x, which is cosine of 2x times 2 by the chain rule. Okay, so what did I say? After each application of the L'Hopital's rule, take some time to simplify this expression. Okay, so let's write this in a slightly better manner. So this is going to be equal to sine of 2x times cosine of x over 2 times sine of x cosine of 2x. Okay, so what happened here, right, this can be written as limit of cosine of x over sine of x over 2 times cosine of 2x over sine of 2x. And then this is a complex fraction. How do I multiply the outer with the outer element divided by the inner over the inner element? And that's what we get here. Now try to check what is happening with the numerator. Sine of 0 is 0, so the numerator goes to 0. And the denominator, sine of 0 again is 0, so the denominator also goes to 0. Now this is a perfect example where applying the L'Hopital's rule here certainly will work, but it's going to be more difficult to use the L'Hopital's rule in this case rather than using the knowledge that we have how to solve these limits from Cal 1, especially the limit sine of theta over theta as theta goes to 0, that is equal to 1, and the limit of theta over sine of theta as theta goes to 0 being also equal to 1. Why do I say this? Well, limit as x goes to 0 from the right, I have sine of 2x, so in the first case here, theta is 2x, so this is my theta here, let's call it theta 1, and I have to divide it by the same angle. So I already have 2 in the denominator, so I just multiply it by x, and here I have sine of x cosine of 2x. Okay, now look at this. Sine of 2x over 2x is sine of theta over theta, and theta goes to 0 as x goes to 0, so this ratio will go to 1. Somebody might have asked the question, well, what happened? How did we get this x from where? Well, we just multiplied the denominator by x, and that is unacceptable. So I have to multiply the numerator by x in order to have this fraction being equal to this fraction. And when we do that, now I have x over sine of x, or theta over sine of theta, as theta goes to 0. So x over sine of x by this limit goes to 1. And now, what do we have? We have the limit as x goes to 0 from the right of cosine of x over cosine of 2x, that's 1 over 1, which is equal to 1. Cosine of 0 is 1. Cosine of 2 times 0 is 0, so cosine of 0 is 1.